one girl, I don't remember her name. Unka baki sabka is zero. I've already updated. Please see it. See,
No, no,
this.
assignment 12, that is understanding blockchains.
Yeah, I'm not. See, I think one of them I've not done it. Remaining all I've done. I'll do it today. Little bit I'm busy. I'll do it.
Yeah, yeah, sure, sir. Thank you.
Okay, very good afternoon. Welcoming you for the last session this week, which happens to be your fourth session in this module, module 5. Fourth, and after this, we have three more, which we shall be having the next week, and we wind up this module of yours. So, I hope you can see this Remix Ethereum in front of you. Can you tell me what is that we did last yesterday? Tell me, what did we do last yesterday? What happened? Why are you silent?
So syntax we
of
learn.
of what we were
Uh,
seeing the parts or the components of a smart contract where we did till variable length byte array, where we had used the example of yours itself. I have forgotten Nishiban. We used the example of Nishiban where we told the local byte as Nishiban, and we have shown this example. Continuing with this, we do on string today. You all must be pretty much aware of what a string is in C. How does a string end with in C? When you end a string in C, how do you end it with? Anybody? Nishiban, what do you say?
so string, then
Yeah.
double inverted comma, and between the
No, no, no. Yeah, it is inverted comma slash zero. That's all.
you can write anything, sir.
Yeah, yeah. Now, see, not like in C, string in solidity does not contain a terminator. Therefore, the actual space allocated to string test is 4 bytes. So, what we see within this is the concept of an array. What we can do, we can use the keyword new to create a memory type array. The major difference between memory and storage array is updating the length property cannot adjust the array size enough. We said we can use this keyword new to create a memory type array. And the major difference between memory and storage array is updating the length property cannot adjust the array size through. So what we will do, we will take a small little example to understand this on how do we create a storage array. We know how do we start off a smart contract. We say pragma solidity, I say cap 0.4.0, give a semicolon. Then let's say it is a contract which we shall call it by the name of example. And we define a function which we say is f of, which is the function, and then a curly brace. Then we say we create a memory array. Can you tell me how do you create a memory array, which we had seen in yesterday's class? Anybody, please tell me. I want to create, after I specify my contract, the name of the contract, then a function, then I need to create a memory array. How do I create a memory array? Bolo bhai, won't I say unsigned integer, and we will say memory of A equal to new unsigned integer, and we say as 7. We will come back why we are using all these things over here. See, we cannot update the length property of memory array. So which is what we just cannot do in Solidity. And after this, what we do, we specify our storage array, for which we say once we say unsigned integer and of B, a semicolon, and then we specify a function as G and curly braces. Then we say B is new unsigned integer. Once again, we give it this value 7, and here also we can adjust array length through setting length property. Once you set the length property, you can adjust the array length. So what we specify here, we say b dot length, let's say it's 10, and we say b of 9 and give it a value 100. This is how do you set an array property here. Here there are quite a few things which we have used. We shall tell you what it is. See, in this code, this f which I've used in line number 6 tries to adjust the length of memory array, and compiler gives the error information that the expression has to be a 1 value. However, in this G which I've used in line number 11, for storage array, we can change the size of the array through updating the length property. And the length properties are bytes or string. Bytes means it's a dynamic byte array. It is not a value type. And string means it's a dynamic UTF-8 encoded string, and it is not a value type. Have you understood this, or you want me to repeat it once more all over again? Tell me please. Anybody wants me to repeat it, or you're comfortable with what I have told you on these arrays? Tell me, I just can't see you because you were not on the screen, and as it is, I don't remember anybody's names. So you'll have to tell me. Once more, I can tell you what do you mean by array. See, we can use this keyword new. Once we use this keyword new to create memory type array. And the major difference between memory and storage array is that updating the length property cannot adjust the array size, which we have taken an example and solved here, where we have created a storage array by the name of unsigned integer b, which is which as you see in line number 10 of mine. And in this, what we have said, we have used this function f in line number 6, which tries to adjust the length of memory array. And once you try to adjust the memory of the length of memory array, the compiler gives you an information saying that it is an error. The expression has to be of a 1 value. However, in this G, which I've used in 11, for the storage array, because the storage array creation starts from line number 10 till line number 14. So in this line number 11, where I've used this G function for storage array, we can change the size of array through updating the length property. That's all what I've told. Is it clear, not clear to you? Tell me. Tell me, or is it that you got disconnected? The only thing I can do is go back and ask you, Pratyush, Jag, Yug, Chandak, Nishuban, have you understood what I've told?
Yes, sir.
Okay, let's see on the next thing. See, all these things, please understand, these are extremely important when you create an array. When you create a smart contract, you need to know all these things. It is not that simple. You need to know all these things, and as it is, all these things are there in your syllabus. And we are just touching the very, very fundamentals of it. The next, what we see is what is called struts. Struts is used to define user's own data structure, which is a composite data type, and it can include different type of member data. See, there is no code in struct, and struct is composed of variable only. Once again, struct is used to define user's own data structure, which is a composite data type, and it can include different types of member data. There is no code as such in struct, and struct is generally composed of variables only. So when you write a struct in Solidity, it looks something like this. You say struct, let me give it a name as funder, a curly brace, and then we say address as ADDR, a semicolon, then we say unsigned integer as amount, again a semicolon. That's all. This is what is a struct. So if at all anybody asks you as to what is a struct, you have to please tell them that struct is used to define user's own data structure, which is nothing but a composite data type, and it can include different type of member data. However, struct does not have any code in it. It is just composed of variables, and you can give this example. Are we comfortable till here? Tell me, unless you guys interact and tell me whether you have understood, not understood, there is no way I can know, because I am not at your place where I can physically call you and ask you. Tell me.
Understood, sir.
Yeah. The next thing what you require in a smart contract is what is called mapping. Mapping is a kind of key value pair. The syntax is like you can say key type, which is nothing but the key value. I'll show you an example. The key can be any type except mapping, such as array, contract, enum, struct, etc. Once again, I shall repeat it. See, mapping is a kind of this key value pair. And the syntax, when you write mapping, it is something like this. Key type, you have equal to, this greater than, and you say underscore key value. Here, this key can be any type except mapping, such as, say, it can be array, contract, enum, struct, anything. And in smart contract, the mapping is written something like this. You say mapping of address, which is nothing but unsigned integer of, we shall say, public balances. That's all. This is what is mapping. You may take little bit of a time to understand it, but please understand it and write it in your wherever you're writing, if at all you're writing. Have you understood? Please tell me. Have you understood this? What do you mean by mapping?
Sorry.
Repeat. Okay. See, mapping is nothing but it's a kind of key value pair. And the syntax I told you for mapping, it is key type, which is mapped to the key value. And here, this key can be of any type except mapping. And it can be anything like array, contract, enum, struct, anything. And the syntax for mapping in Solidity is like what you see on the screen. where in this I have mapped addressed this unsigned integer has been mapped to address, and it is just one line. How do you represent mapping? Is it fine?
Yes, sir.
Okay.
Sir,
Yeah, tell me.
so address is the data type over here.
Address, yes, it's the data type.
Okay, sir.
Okay. See, although there are quite a few words which you might feel you are hearing for the first time, but see, once you read through it, it is very comfortable. You will find it's really comfortable. Okay, the next what you need to see is on what is a statement. See, Solidity does not support this switch and go to statement. The bracket which you use in a if condition statement is not omittable, but in the single line statement, curly bracket can be omitted. And in the statements that we shall see, we shall first see on the conditional statement, which is this if else. In Solidity, if else is just like other programming languages, but if this if else code block only contains just one statement, which is curly brace, this could be omitted. In Solidity, if you really want to use the statement saying that if within bracket 1, you should force a typecast to convert 1 to Boolean value true, which I shall show you by some example. I said this conditional statement which we shall be seeing now. The first one is this if else statement. In this if else statement, it is exactly like the if else of other programming languages. But here, if this if else code block contains just one element, say maybe you say a curly brace, you could definitely omit it. We shall see this with the help of some lines of code in Solidity. Just this patch of code for this if else statement. Say we say if, and I say total points is greater than bet dot line, and then we say balances of bet dot over, this will be plus or equal to, that is balances with bet dot over plus bet dot amount, let's say times 2, give a semicolon. Then what we use, you use else if. It's written this way, it's written with a gap, else and then an if, sorry, else and if. Else if total points less than bet dot line, we shall say balances of let's say bet dot under, this will be this plus bet dot amount times 2, a semicolon. And since I've used if and else if to terminate this, I have to use the else. I say else, let me say we are giving refund for ties, for which we shall say balances of bet dot under, which will be nothing but this plus bet dot amount, a semicolon. Also we shall be saying balances of this bet dot over, this will be this value plus bet dot amount. That's all. This is how a conditional statement is written, and definitely this, since I've used a curly braces, this will end with a curly brace. Since I've used a curly brace in line number 8, it has to end with a curly brace. This is how you use a conditional statement of if else. Like I've been telling you, 2 places you will definitely encounter this, maybe in one of your exams or your test or whatever, And the second, definitely, if you for all you interested guys who would be working in this field, which I shall suggest, if you're considering for a big jump in your career, you have to work in this field. It will give you a big boost. So have you understood this if, else if and this else statement? Any number of else if you can have in between. I have just used one of them. Have you understood this?
Yes, sir. So
Okay.
we use curly brackets in if and if else block.
No, we use curly bracket. Here I have used curly bracket only in this else block because I'm giving refund for the ties. Remaining all are the regular brackets. No curly brackets anywhere else.
Only in else.
Yeah, that's why you find that yellow colored one circle around my curly bracket. On its own, it has come up because it is referring to this closed curly bracket of my line number 11.
Okay, sir, got it.
Okay, fine. Let's,
And sir,
yeah, tell me.
the bat that we used over here is a structure.
Just for the sake of it, I don't refer to it as anything. It is just, that's why I said it's just a small patch on the code. I don't refer it to structure. I don't refer it to anything. Just wanted to show how this code works. Don't worry. When we write a bigger contract, a smart contract, all your ideas would be clear. Is it fine?
Okay, sir. Yes, sir.
Let's now see on this while loop in Solidity. So when I use a while loop, it would look something like this. Let me just knock it off. I shall say that this is a while loop. And my while loop would be, let me say, unsigned integer of insert index, which is nothing but my stack dot length. And then we say while insert index, this is greater than 0, then I use 2 times ampersand and I say bid dot limit, which should be less than or equal to stack of this insert index minus 1. And this I would want to limit this value. So close my bracket, then induce another curly bracket, then I say insert index and hyphen and semicolon. That's it. Did we miss out on a bracket somewhere? Why is that we are having another regular bracket? Insert index, we should be closing it at limit. I don't think we need this. No, there's a curly bracket. Fine, you need to close it here. That's fine. This is the example of a while loop. Don't worry what I've written inside. It is just simple example of a while loop. Just wanted to show you how a while loop looks like. Are we comfortable till here?
Yes, sir.
Okay, you may, I shall suggest to you, you may write it down somewhere and keep so that it helps you out.
Yes, sir. Yeah,
Okay,
we are noting down.
that's fine. Maybe take little bit of a time. You should not tell me that I'm running, I'm going very fast. No. Are we at a comfortable pace or do you feel I'm going fast?
No, sir, it's fine.
Okay, fine. Please tell me in any programming language, what do you mean by a modifier? What is a modifier? Okay, fine. Let's see this in our case of Solidity. See, the function declarations use some kind of a template like what I shall show you. This, which what we shall be writing will be how a function declaration would look like. It shall be function, let me say xxx of some parameter types, and I shall give then we have a curly brace and we say internal default, and we pipe this value with external and close the curly brace, and then we say some constant which we shall say in square braces. Also we say some payable, and which we shall say returns some kind of a return type. Return types. Close a regular curly brace. That's it. This is the how a function declaration is done. You in somewhat in this template. See, beside function name and parameters, we can add modifiers. So we will introduce you to what this modifier is, their usage and difference. The first kind of a modifier is what is called as a standard modifier. Please, you may write it somewhere. This is the first kind of a modifier in Solidity, which is called a standard modifier. And functions like state variable has visibility modifier, and possible visibility modifiers are something like what I may write for you over here. See, we said functions like the state variable have visibility modifier, and possible visibility modifiers are external, internal, and we say default, and also it can be public, default, and private. See, function also has other modifiers which specify the accessibility or mutability of the state variable. So this is what we have told is a standard modifier. Under the standard modifier, there are a few types of standard modifier. The first of that is what is called as an internal modifier. See, functions and state variables defined with internal can be accessed from internal. And like this current contract or current inheriting or the contract that is inheriting from it, you need to note that do not use this keyword, that is this internal modifier, since this keyword indicates that it is external access. If there is no modifier, internal is the default modifier. And internal is similar to protected keyword like you find in Java and C++. The internal function is not accessible from external, and it is not a part of the contract interface. You need to remember this. Have you got it, or do you want me to tell you once again before we get into little more confusing terms? Have you got it? What is an internal modifier?
Sir, repeat.
Yeah, we said this function and state variables defined with internal can only be accessed from internal, and the current contract or contract inheriting from it. But I even said a small word of advice. Please do not use this keyword here, because since this keyword indicates that it is external access. If there is no modifier, internal modifier is the default modifier. What you need to remember, if at all you don't specify the modifier in Solidity, by default it is the internal modifier. And internal is similar to protected keyword in, say, the languages such as Java or C++. The internal function is not accessible from external, and it is not a part of the contract interface. Are we comfortable till here? Tell me. Or once more. Okay, great. We also see another kind of modifier which is very important for you, which is the external modifier. See, you can call in external functions from an external contract or through transaction, since external functions are a part of the contract interface. For any external function, say if I say f, it cannot be called from internal. Say for example, if I say F regular brackets, this is invalid. But if instead of this, if I say this dot F of open close bracket, this is okay. External functions are more effective in receiving a big size array. Once more, see, I said we can call these external functions from an external contract or through transaction, since these external functions are a part of the contract interface. For an external function, say F, it cannot be called from an internal. That is, if I just say as this F open close, regular F open close bracket, this is invalid. But instead of this, if I say like what you see, what I've written here, this dot F open close bracket, it is perfect. External functions are more effective in receiving a big size array. Incidentally, tell me, when is which month do you have your final exams? Is it in the month of May?
Probably is a main.
Yeah, but you know what is I would say the worry with me today. We are in just the beginning of March, and definitely 100% before end of March we'll finish the syllabus. Then there is a big month of April in between where you will 100% forget everything. Not 100, 200% of these concepts you will forget. So what will you write in May? See, all these concepts see, the other subjects are perfectly fine. It's more or less maybe little bit boost of what you've done earlier. Since this subject is totally a new subject for you, and with the lack of availability of books like at your place, it is going to be a scary journey. Don't worry, despite all this, anybody, anytime you can revert back to me, we shall help you out. Let's also jump back and see what do we mean by public modifier. See, these public functions are a part of the contract interface, and it can be invoked through internal or external message call. And for public state variable, the compiler will create getter and setter function, which it does automatically. Are we comfortable till here? That is, are we comfortable till we have spoken on this public modifier? Tell me. See, for the first modifier we spoke about, which we said the first modifier is the standard modifier. The second modifier is this public modifier. The next one I shall tell you after this what it is. Under the standard modifier, which we spoke of initially, we have this internal and external modifier. The next kind of modifier is public modifier. And I said these public functions are a part of the contract interface, and it can be invoked through internal or external message call. And for public state variable, the compiler will create getter and setter function, which it does automatically. Are we comfortable till here?
Yes, sir.
Okay, since we have spoken on public modifier, let's also see what do we mean by private modifier. Private functions and state variables are only visible to the current contract, and they are not accessible from the inherited contract. And private functions are not a part of the contract interface. Please remember this. And maybe in half a minute or so, we get hands-on with all these things what we have spoken. We said these private functions and the state variables are only visible to the current contract. They are just not accessible from the inherited contract. And private functions are not a part of the contract interface. So this gets us to another wonderful concept of what we really need to see, which is called constant modifier. Since we have seen public, private, we also need to see constant modifier. The constant functions cannot modify state on a blockchain, but they can read the value of state variables and return it to the caller. Constant function body is not able to change variables, create another target, trigger event, and invoke other functions which may change the state on a blockchain. Constant is included in the functions JSON's ABI file, and it is used by web3.js JavaScript library to determine a function call which is initiated by transaction or maybe even by a direct call, which we shall see a small little example. But before that, please tell me, did you understand by what do we mean by this constant modifier? Tell me, please. Yes or no? Or 50-50, somewhat yes, somewhat no.
Sorry, repeat.
Yeah, see, this constant functions cannot modify the state on any blockchain, but they read the message, they read the value of the state variables and return it to the caller. The constant function body is not able to change variables, create another contract, trigger event, and invoke other functions which may change the state on a chain. And constant is included in functions JSON's ABI file, JSON ABI file, and used by web3.js library to determine a function call which is initiated by a transaction or maybe a direct call. So we will see what this constant modifier is, practically writing something for us on Solidity. Let's now create a contract. Let me call it hello visibility. So I say contract hello visibility and start off with a curly brace. Well, the first thing in a contract, you need to specify a function. I say my function is hello, which is nothing but a constant and returns a string. And after this, I shall again induce a curly brace and return hello. That's it. And after this, once again, I'll create a function called hello lazy. So here I shall create a function by the name of hello lazy, and we shall say this is a constant and returns a string. Again a curly brace and we return hello, semicolon. That's it. So this will return this function hello lazy. So now what we will do, we will call another function called hello again. So we say function hello again, constant returns string. I have another curly brace. I say return hello, and I say return hello again, and a semicolon. So, and apart from this, we shall also create one more function. We say function hello white, hello white, which is a constant. I shall say a private returns string, and we will have a curly brace. Let it return hello. That's it, and our contract hello visibility is over. In this here we have used this hello functions. These hello functions can be called by any other contract, including by itself. Other functions in the contract can call this hello quite function directly, and also this hello again. But if hello quite, which you have shown in the last few lines, is called from an external contract, an error will be raised. In this example, all functions are declared with constant since they will not change the world state. You may write this. Definitely, I shall expect somebody to ask me some question. If you don't want, tell me again. We shall repeat it again for you. But first, you please write this.
So what is the difference between hello function and hello again function? Oh, okay, got it.
Got it? Okay.
Okay.
You please write it, and wherever you want, you put a double slash. Write a comment, so that you the next time, because there is this dark month of April in between before your before we finish and before your final exams. So in the dark month, definitely you will forget it. It is just human to forget.
Sir, hello again function, what it will return?
See, hello again function. It okay. Sorry. The second last line is not hello again. It returns hello.
Lazy
Yeah.
or
Hello.
okay.
My mistake.
Done, sir.
Done. See, you also have what is called as pure modifier, and this pure which are used, it specifies more constraints for functions. And pure cannot read or write state variable, and function modified by pure cannot access current state and transaction variables. And apart from this, you have even something called as payable modifier, and these payable functions can accept ethers from the callers. If sender does not provide ether, call may fail, and payable functions can only accept ether. That's it. You can just accept only ether. So definitely there is some difference between these modifiers. Let's see what are these differences. The first, what we can do, we can see the difference between external modifier and public modifier. See, from the visibility point of view, external is almost the same as public. After this public or external functions in the contract are deployed to blockchain, functions can be called by other contracts, though through direct call or transaction. See, the main difference between external and public modifier is how they are implemented and how parameters are processed. In contract, a call to a public function is implemented by something called as a jump opcode, just like private and internal functions. While external functions are implemented using something called as a call opcode. And besides, the external functions does not copy any parameters from the call data to memory or maybe a stack. So I shall show you an example of how external and public functions, how they behave differently, if you have understood the small little story which I've just told you. Have you understood this, what I told you, the difference between external and public? Or you wanted once more?
Yes, sir, repeat.
Yeah, see, we said from the general visibility point of view, external is almost the same as public. See, after public external functions in the contract are deployed to the blockchain, functions can be called by other contract through, you can say, direct call or transaction. The main difference between external and public is how they are implemented and how parameters are processed. In a contract, a call to a public function is implemented using this jump. What I've written for you on the screen is implemented using this jump opcode, while the private and internal functions, while external functions are implemented using this call opcode. And besides the external functions, they do not copy parameters from call data to the memory or stack. So we shall write a small program to see how external and public functions behave differently, which will be clear from what we write here for you. So we shall say pragma solidity cap, let's say 0.4.12, the semicolon, then we say contract test. Brace, let's write a comment. We say this can be called by internal or external function, and since internal function read parameter from memory, Solidity needs to copy array data into memory, and it costs some extra gas. I'm sorry, I've written in caps. It has to be sentence case. It is pragma solidity cap 0.4.12 and semicolon. We say contract test, and since I want to write multi-line comment, I shall say hash and star. Then I write whatever I want. I say these are the comments. This can be called by internal or external function. Since internal function read parameters from memory, Solidity needs to copy array data into memory, and it shall cost extra gas. That's it. Since this is enough for us, so what I do, I once again close it, so star and a slash. Now what I do, the first thing, like you all know, we need to create a function. I say function test of unsigned integer, say 20, and this I would say is public returns of unsigned integer, and we shall open a curly brace, which we shall say return a of 10, let's say 10 times 2, semicolon, close our curly brace. So this will close this curly brace, and then since we are seeing on this jump and call, what I'll do, I'll write few more lines of comments for you, which we can say that this call data cannot be called. The top what you have written is for this jump. So down below we shall write how does a call data look like. And in this call data cannot be called from internal, and it reads parameter directly from the call data, and there is no need to copy parameter into memory. So we say cannot be called from internal, and it reads parameters directly from call data, and there is no need to copy parameter into memory. That's it. Let's close our comment and then let's write our function test, which will be unsigned integer of say 20, and we will say this will be external returns of unsigned integer, and thereafter we give a curly brace and return a of this 10. Let me say this is 10 times 2 and a semicolon. That's it. Then after this, this we have told this part of this thing for our call. So let's even see the jump opcode. For this, what I'll say, this would be, let's invoke jump opcode. And this is an array type parameter here is passed through pointer to memory, and the function body access parameter through the memory pointer. So what we will do, we shall close the comment and create a function over here too. We say function of, let's say, test of unsigned integer 20, and this we shall say is internal returns of unsigned integer, and let's have a curly brace where we return a of 10 times 2 and a semicolon. Here the only thing, since I've used this a, I have to give a this way here, and in the previous one also, since I have told return a, here I have to give a and a bracket, and the one above here also I will have to give a bracket. Since I have told return a, there will be a space between return and a. That's it. Done. You're done with this code. And what is this code? We shall speak on this once again when we catch up tomorrow, where we will write this code and we will speak on this. Don't worry, you don't need to break your head. We can speak on this when we catch up tomorrow. So let's do the small. Is there anybody who's writing it still? Or you already given up?
No, sir. It's done.
Done? Okay. Let's take your attendance, please. Please answer your attendance. Okay, 521013, 59590, 619169, 989832, 466905, 443952, 496596, 733011, 15001, 15002, 15003,
Present,
15003,
03.
15004, 15005,
Present, sir.
15006, 151001,
Present, sir.
151002, 151006, 151007. 6%. Okay. 151007, 151008,
Present, sir.
151010,
Present, sir.
151012, 151013,
Yes, sir.
151014,
Yes, sir.
151015,
Yes, sir.
151016,
Yes, sir.
151018,
Present, sir.
151019.
Yes, sir.
Rituraj Singh Rathod.
Yes, sir.
151022,
Present, sir.
151024,
Present, sir.
151027,
Sir.
151028, 151029,
Yes, sir.
151030,
Present, sir.
151031,
Yes, sir.
151035, 151037,
Present, sir.
151039, 151041,
Present, sir.
151044. 151045.
45 present, sir.
151048.
Present, sir.
151001.
Yes, sir.
151002.
Yes, sir.
Aniket Charanya.
Yes, sir.
Harsh Damecha. Anand Godani.
Yes, sir.
Kavan Prajapati.
Yes, sir.
Rushi Kanjaria. Kishan.
Yes, sir.
Moil Balani. Parth Pokar. Vinod Rathod.
Yes, sir.
Rikin.
Yes, sir.
Meet Safsani.
Present, sir.
Sitanshu. Tilak Ved. Parasbhai Viradia.
Yes, sir.
Abhishek Trivedi. Chintan Lakani.
Yes, sir.
151036.
Yes, sir.
Thank you. Have a nice day.
Sir, sir, 007 present.
007.
151,007.
Okay.
And sir,
1014.
0004.
4.
Yes, sir.
Triple
And
04.
39.
One second. Where are you? There is no 000. There's no 004.
0004, 0004, sir.
One sec. Yeah. Okay. Anybody else?
39.
39. Okay. Anybody else? Thank you. Have a nice day.